Right. So let's take a look at our kinematics. Before we do kinematics, everybody should differentiate by now. Let's just look over quickly how to integrate. And it didn't really ask you hard integrations. But if you have to integrate 5x to the power of 4 minus 3x squared, how is it integrate again? Add 1 to the power. So you're adding 1 to the power and you're dividing by the new power. Sorry. So it will be adding 1 to the power divided by the new power. Adding 1 to the power divided by the new power. And yeah, plus C. This will cancel. This will cancel. Right? What would happen if I had limits? If I had the limit, let's say 7 and 4. What you do? Substitute 7, substitute 4 and subtract the values, right? Do you write plus C? No. Right? So you have your 7, you have your 4. So you plug in 5 to the, you plug in 7 to the power of 5, 7 to the power of 3, you plug in the 7, work it out, plug in the 4, work it out and subtract it. That's okay? Right? That's how you integrate functions like that. You need to also be able to integrate functions that look like this. What's the integral of 2x minus 1 to the power of 3? What do you do here? Huh? So you write back here 2x minus 1 here. Add 1 to the power. You divide by the new power. And what else? And you divide by the differential of the bracket. Okay? Differential of the bracket is 2. And you write it plus. So the answer will be 1 over 8 by 2x minus 1 to the power of 4. Quickly, since you look like you put something here now, integrate this one, please. Integrate that and plug in your answer. Write the integral between 3 and 2 of 5x minus 1 cubed. Right? Remember, you can also check this in the calculator, right? Right, online, they'll give me a message, right? Right, remember, once it starts to integrate, you don't write back the integral symbol, right? You add 1 to the power, which is 4, divide by the new power, right? And divide by the differential of 5x minus 1, which is 5. Right? When you begin to work it out, right? This is 1 over 20, so leave that outside. Right? Leave that 1 on 20 outside. And then plug in a 3 and then plug in a 2. So that's 5 by 3 minus 1 to the power of 4. And then this is 5 by 2 minus 1 to the power of 4. Right? Plug in a 3 and plug in a 2. How much you got? And you work it out? 6,000. 71 all over 4. Anybody else got that? Okay, good. Ariane got that. Tarisha, nice. Yeah, okay. Right, so that's a quick review on how to integrate. We also need to be able to integrate trig functions, right? Right, nice, Jovan. Right, remember, all those who want to do the cash was face to face, even if it didn't pay as yet, put on your names, right? Put on your name on the list, right? You have until, well, around the deadline.
You don't want this.
Right, 1, 2, 3, right? How do we integrate? How do we integrate cos 3x? Right? So to integrate cos 3x, we integrate cos and we'll get sine, and then we put 1 over the differential of 3x, which is 3. Right? So it's 1 over the differential of 3x by the integral of sine, and then you write back 3x. Right? Listen again. The integral of cos is sine, right back 3x. But you still have to work out this part here. It's 1 over the differential of this here. So 1 over the differential of 3x, which is 3. Right? So this part here is the differential of what you have here. Okay? Do me a favor, integrate this, and I'm giving you limits, right? Integrate between pi on 2 and pi on 4. Integrate cos. Actually, integrate 2 sine 4x. Integrate 2 sine 4x between pi on 2 and pi on 4. I should cut it off. Oh, Sydney. Sydney, you mute your arm. Anyway, I'm muted for you. Go ahead. Try that. Just a quick little check, right? And then we can start feeding up. Finish? About it, do you know how to integrate this? What's the integral of sine? Minus cos. So the integral of sine is minus cos. Right? And you can take it 2 and put it outside. So it becomes 1 over differential of 4. Then you can bring back it 2 here if you want. That's all. So basically it's 2 over the differential of 4x, which is 4. Integral of sine is minus cos, and then you write back the 4x. And you still have to plug in your limits. Pi on 2, pi on 2. Check your answers and see. . pi on 3 on top? No, pi on 2 and pi on 4. Much all got? -1. Okay, nice. Let's move to kinematics now. -1, nice. Dimitri, check yours. Okay. Right. Let us take a look. Okay, now? You got it, value? Right. So look at kinematics. I am only going to look at one side of it, right? The integration, but now let's explain everything, right? When I say one side, I mean this, right? So we're looking at 3 quantities. We are looking at displacement. We are looking at displacement, which I'll denote by S, velocity, right? Remember, displacement is distance moving a stated direction. Velocity is what? Changing displacement over time, and then we have acceleration. Acceleration is D. All right. So how do we go from displacement to velocity? Well, velocity is ds dt. So if you differentiate the displacement, if I give you an equation and you differentiate displacement, you'll get velocity. Right, Elena? If you differentiate velocity now, you will get acceleration. But as I told you, you may not see this side in your exam. In your exam, you will see this here. To get velocity, you have to integrate acceleration with respect to time. That's okay? To go to velocity, to go to displacement, you have to integrate velocity with respect to time. All right? So we are going to look at this side here, not this side. Okay? I'm going to give you acceleration as to find velocity and so on. Okay? Copy it down, and just for those who not doing physics, just take a small explanation of what each one is, right? Right, just to take a small definition, look at each one. Displacement is the straight line distance from the start. Straight line distance from where you start to where you finish. Displacement is the straight line distance from start to where you finish. Velocity is the rate of change of displacement. Velocity is the rate of change of displacement. Right, SI unit. SI unit is meters per second. MS minus 1. Acceleration. Acceleration is the rate of change. Acceleration is the rate of change of velocity. Rate of change of velocity. SI unit ms minus 2. SI unit ms minus 2. Right? One thing that we need to remember a couple of things. Just know this, right? Note that if you have constant velocity, sometimes you see this word in, right? Constant velocity, what that means is that you have no acceleration. Right? So it's I know a little bit of this physics. So constant velocity means the velocity remaining the same and you have no acceleration. Right? That's constant velocity. The next thing you need to know is that at maximum height, what has happened? If you reach a maximum height, then what you can say, velocity is 0. So your velocity is 0. Right? And if they say instantaneously at rest, again, it means velocity is 0. Right? They like to have these little things, right? Right? Also remember that velocity is a vector quantity. So if one direction positive, the next direction negative. Okay? One positive, the next is negative. All right, so make a little note and let's see if we can try one now. All right, so that's kind of the theory. The next thing that we need to be able to do is to integrate the work questions like this, right? Right, take a little read of this one. Take a little read and let's talk through it and then you will try it. Take a little read. We'll do some talking about it and then we'll do some trying. Right, so as you read it, you have to pick out information, right? Pick out all the information here.
Pew, pew, pew.
Hey, come back with a scarf. Come on, sit down here, big boy. Just want to sit down and cool it. Ah, well, I see about him. I see about yeah. Hijab again. All right, ready? Ready? You log in on Saturday. Bad maps. This is the maps. What's your first name? I was messaging somebody this second. A particle moves in a straight line so that t seconds after passing a fixed point, the velocity is given by that, right? So they gave you the equation for velocity. Then they said find the value of t, which is instantaneously at rest. How are you doing that? Right. So you're basically taking v is equal to 0, putting it in here and solve for t. That's okay. Then they want the distance moved by the particle between the two values on part 1. How we get the distance moved? Right. To get distance, you have to integrate velocity. So you're integrating velocity. That's okay. But you have to integrate between the answers obtained in part 1. Right? All okay with that? So you have to use the limits on part 1. What about part 3? Find the total distance moved between 0 and 7. How are you doing that? How you'll get the total distance moved between 2 points? Normally, yeah, if you have a distance equation, could you find the distance at 0 seconds, then at 7 seconds, and subtract? All right, try it and see. Right, but I will tell it there's a reason they ask for between 0 and 7. Try part 1 and 2. You want to try part 3? Go ahead. Right? What year? Specimen paper, I think. Right, go ahead. I'll give you a few minutes. Take your time, do your integration, plug in your values. Let's see what you got. Really?
Here, please, what do you stick number? 600.
Give me a
All right, are they get through? All right, so let's check out part 1 and 2. I don't know. And I'll go and do it. I do not know. So let's see. Part 1. Let's check out part 1. So they said when instantaneously at rest means b is 0. So that'll be 3t squared. Oh wait. Those who are not taking this off, right? And it's on the board. So it would be 3t squared minus 30t plus 72 is equal to 0. When you solve it, you'll get t is what?
600.
6 and 4?
Yeah.
Right. And then part 2 now, they wanted to get the equation for s, right? So s is equal to integral of v with respect to t. So that's the integral of 3t squared minus 30t plus 72 with respect to t. Right? I saw some people when they're doing questions like this, right? They want to divide everything by 3 to simplify it. You can only divide by 3 if it's equal to something. It's an equation. If you divide this by 3, you're going to change the actual equation, right? So don't do that. Okay? Just integrate right in. Right? So if you want to avoid having to get the C value, you could have plugged in 6,4 here. But you need to get the C value. I'll show you how to get it. S is equal to 3t squared. So that'll be 3t cubed all over 3 minus 30t squared all over 2 plus 72t plus 2. Right? When you simplify this, you'll get s is equal to, right? S is equal to t cubed plus, minus 15t squared plus 72t plus c. That's okay? How did we get c? If we go back to question said that the t seconds after passing a fixed point O. So basically, it started at a point O, which means that when s is 0, t is 0. Okay, so you start at a fixed point. If you start at a fixed point O, then the displacement t is 0. That's okay, and the change as in move away. So when s is 0, t is 0. So plug in 0, 0, and you'll also get t is 0. Right? So somewhere in question, it tells you when t is 0, what s is. That's okay, you have to look for that. And then let's finish it up. What they asked for right. So the one s now between those two values, right? Yeah, between being at rest. So it's between s is 6 and s is 4. Right? Sorry, we don't have to integrate because we integrate already. So between s is 6 and 4, we have to plug in t cubed minus 15t squared plus 72. So that's 6 cubed minus 15 by 6 squared plus 72 by 6. Minus, plug in the value with 4. So that's 4 cubed minus 15 by 4 squared plus 72 by 4. Right? How much is that? Negative? Minus. And it will go this on this? Yeah. Right, how much you got here? 100 and?
812.
This is 112. Right? So the I want to show you this now. I want to show you what probably happened. All right, so basically, here's what happened, right? The question asks for the distance moved between those 2 points, right? So when t is 4 seconds, that was the displacement. When t is equal to 6 seconds, that was the displacement. So what that meant is that here's 0, here's 4, here's 6, time-wise, right? Time. So it appears that they would have traveled this way. That would have been 112 meters. And then for the next 2 seconds, they went back a little bit. So this is 4 seconds and this is 2 more seconds. So that's 6 seconds here. So they went back to about 108. Right? So it means that between 4 seconds and 6 seconds, he would have covered a distance of 4 meters. Y'all seen that? Y'all seen that there? So he would have covered a distance of 4 meters. Because you see, when the displacement is 112, right? He would have measured a little bigger, a little smaller. So you started here and you traveled in 4 seconds, you reached this point here. This is t is equal to 4 seconds. And the distance is 112. Right? So after 4 seconds, you traveled 112 meters and it came to rest. Right? And then you travel 2 more seconds in this direction. Remember how you find this displacement? Displacement is straight line distance from where you start to when you finish. That's okay. So if your displacement now is 108 meters, it means that your distance from where you start to where you finish has to be 108. That's okay. So it means that from here to here is 108 meters. That's okay. That's the way you measure displacement. The distance from where you start to where you finish. From where you start to where you finish. That's okay. So right here is where you reach when t is 6. So what's the distance traveled between 4 seconds and 6 seconds? This distance here, which is positive 4 meters. Right? 2 things are where to identify the actual distance. That's not vector quantity. So you do put the negative sign. Right? So you put 4 meters alone. Right? Somebody was saying that, huh? Elena? I mean, Justin here? Right? So it's 4 meters. Okay? So therefore, that's the reason why. Right, now we have a next problem. What they asked us for after? They asked for the total distance traveled between between 0 and 7 seconds. So you cannot just plug in 0 and plug in 7 and minus. Right? Here's what happened. Here's what appears to have happened. When they reach 4 on this top, they went in the next direction. So when they reach 6 now, they just stop. So we're not sure if they continued in that direction or they went back this way. So we need the total distance traveled. So from 0 to 4, 112. From 4 to 6, 4. Now we have to figure out what happens from 6 seconds to 7 seconds. If you went this way or if you went back the next way. All okay with that? I'm gonna explain it again, right? So from 0 seconds online, you'll follow. So from 0 seconds, the question won the total distance from 0 to 7. Okay? So from 0 to 4, he traveled 112 meters. Right? And from 4 seconds, remember he stopped at 4, then he went to 6. He stopped at 6 again. So from 4 seconds to 6 seconds, he traveled 4 meters. Not this value, huh? Not this value. Right? This is displacement at 6 seconds. So at 6 seconds, how far away is from the starting point? That's this value here. Right? 0 to 4 seconds, that's how far you is from start to finish. Right? Remember, you're trying to find the total distance traveled. So from here to here, you traveled 112 meters. That's 4 seconds. At 4 seconds, now we change the direction. How we know that? Because this displacement is smaller. Right? So you change direction for 2 seconds, then you stop at 6. So the total distance traveled so far is 112 plus 4, which is 116. So from 0 to 4 meters, its distance traveled is 112 meters. From 4 to 6 seconds, he traveled 4 meters. Now we need to know from 6 to 7 seconds how far he traveled. Messiah? Are you okay? What's going on? So what you have to do for me now? Find this amount. Find the total distance traveled between 7 and 6. Okay, let me add up 2 on top. Do not plug in 0 and 7, you'll get it wrong. It will not be the same value. More than likely to be short 4 or short 8 or something. Yeah? Why not sure about online? If you're not sure, I'll do it over again. Huh? Why not sure about integrate between 6 and 7? So integrate between 6 and 7 and 6 and 7 and subtract. That will give it a distance. So could you go? Yes, sure, Sydney. Right. So here's what they want, Sydney. They want the distance travel between 0 and 7. Based on what we learned from part 1, the particle came to rest at 4 seconds and the particle came to rest at 6 seconds. So the total distance traveled in 4 seconds is 112. We found that here already. Right? And then when you are at rest at 4 seconds, 4 to 6 seconds, you travel the further 4 meters. Work it out here. We subtract these two and we got 4 meters. Right? So from 0 to 4 seconds is 112 meters. From 4 to 6 seconds is 4 meters. We have to figure out now, because we figured out the first 6 seconds. We have to figure out what happened in the last second. 6, 7. So you're going to integrate between 6 and 7. Tell me what you get, right? Try it and see. Right, send your answers. Let's see what you. Why am I not seeing some of these messages? People messaging, I'm not, Right, we got the last one. Alina, follow what's going on. So integrate here, Elena. Integrate this. Sorry, not integrate. I mean, Alana. Integrate, not integrate. Use this between 7 and 6. Right? So there was a reason earlier. There was a reason why they make you find where it at rest, right? Some question. There's a question in one of the years, but it did not. You have to figure out who shocks in the direction happening, right? Once you realize again these signs, it means that you change direction. So to find total distance, you have to consider where it changed direction, right? So for this last part, between 6 and 7 seconds, all we have to do is plug in 6 and 7. Plug in 6 and 7 between these values. Right, we already know when it's 6, you will get 108. When it's 7, how much you got? Huh? When you plug in 7, when you plug in 7, you get same 112. Yeah? Again? So when you plug in 4 and when you plug in 7, you get the same value. How much you got? 700 and?
Yeah, 112.
Huh? 112? Okay. So you got 4 meters. So the total distance traveled, what's here? The total distance traveled is 4 meters. Right? So you add up here, your total will be 4 and 4, that's 120 meters. Are you okay with that? Anybody integrate between 0 and 7? What you got? 112. You see what happened? You lost the change in direction. Right? So here's what happened. If you get a what happened to Saya in the last second. So 0, 4, 6. Where did he go? 7. He went this way or this way? He went towards me. Correct. He went back right here. Right? You recognize that? So if you had done it using integral between 7 and 0, you would have gotten back the same value here, 112. Because when they integrate between 0 and 7, it will just give it 0 and this value. That's okay? It's not considering what happened here. It went here and came back here. Right? That's the reason why they separate the question into part 2. Right? Online? Are you okay with that? So the overall answer, yes, is 120. Right? The problem is now to find out. There's one just like this again, but honestly, I cannot remember what year. I want to go through all. Right? So let us take a look at this one here. You don't want to message me anything?
No.
Who messaged in that? All right, let's try this next one. This is 2012. Let's see if we can do 2 more on this one. Try this next one. Got to know a little bit of physics on the these, right? Not this one so much. Right? Not this one. Try this here. Right. Right? So a particle moves in a straight line, write down the equation, do what you have to do. Let's see what you got. Let us see. This one not supposed to be so hard. Yeah. Right, but you have to use the information they give you to find C. when you integrate, use the information they give you to find C. Right along. Yeah, okay. Try to get velocity and get the speed. Alright. Right. I get this thing. Here's two. Here's four. We didn't have, choose it as one big thing. We decided to, I would like to say. We did the whole thing all together, right? We treat this whole thing out, right? Time on, so instead of a room, right? So it should be individual. Yeah, we kind of know how to do it. This way, you didn't solve the seat. Yeah, solve the seat. They gave you something. Here's 2 3 4. Yeah, so the seat, and it should count, so what can get, right? No. This is when I spoke. So you just plug in for. So it's 25 by 20. So you're and all you decide. They treat them individual by T and by person. Treat them individual. Right? So if you 5 T and if you want to. I get fine. Give that. Again, velocity. Yeah. Right. Right, be careful when you're working this out, right? Let's check and see what we have online. Jaden looking good, Tabisha looking good. Any more? Bigger value minus Jaden. Right, that's now we'll see. All right, Amanda looking good. Give me 2 minutes again, then I will do it. All right, let's go. Let's see how it went. Seen some good things, seen some bad things. Let's see how it went. All right, so let's start with one. Let's start with the first part here, right? Right, so to get velocity, look at my statements as well. To get velocity, you're going to integrate acceleration with respect to time, right? So acceleration is 5t minus 1 t dt, right? So we want to integrate this. So the integral of 5t is 5t squared all over 2. The integral of minus 1 is minus 2. Right? You cannot forget the c. How do we find the c now? If we look back at the question, the question said when t is 2, the velocity is 4. Question said when t is 2, the velocity is 4. So 4 is equal to 512 by 2 squared minus 2 plus 2. Right? This is 4, 2 into that is 2, that's 10, that's 8, right across. You'll get c is minus 4. Correct? But I this to see. So now we have the equation for b. b is equal to 512 t squared minus t plus 4. Sorry. Minus 4. Right? So that b is equal to 512 t squared minus 4. So now that we have this, right? Now we can go back to the question and see what they ask. They want to find the velocity when t is 4. All we need to do is substitute T as 4, and we'll get V is equal to 512 by 4 squared minus 4 minus 4. 16 into 16 is 8 by 5 is 40 minus 8, which is 32 meters per second. Okay? Look at my statements, right, Justin? Right, there's a way to move on, right? Tell them what is this, make a substitution, integrate, solve the C. That's okay? Make sure you do that, right? Because watch this simple thing here, we are marked, right? Let's just say you do an integral wrong. Where you have this here, you kind of mark. Right? So you only habits of putting your answers like that, right? Part 2, they want the displacement. That's the integral of the velocity with respect to time. Right? So once you do it properly like this, you can see what is V. Right? You see that V is right here. Here. Right? You see V is here. So you know what to integrate, right? So S is equal to the integral of 512 t squared minus t minus 4. Right? Yeah, they integrate this. Okay? How is integrate this again? So instead of just writing it down, make sure you can integrate it, right? What's the integral of t squared? That'll be t cubed on 3. What's the integral of t? That'll be t squared on 2. I'll bring this together just now, right? What's the integral of minus 4? Minus 4t, and again, plus t. So it's 5 marks, right? So we have some working to do. Okay, so this is the end. So S is equal to 5t cubed all over 2 by 3, which is 6. Right? Minus t squared on 2 minus 4t plus t. When you reach here, we have S. But they gave us some information again to help us find speed. When t is 2, S is 8. That's okay? We need this to get the equation. It shouldn't really affect when they ask you to find the last part, but let's see what will happen, right? Right, but you still need to get S. So S is 8 is equal to 516 by 2 cubed minus 2 squared on 2 minus 4 by 2 plus 2. So work this out. What shall I got to see? Anybody work this out? Just come over again. How much? 34 on 3. The next part now, last part. The last part, they want the S between, I don't have to integrate, right? S between 3 and 0. Anybody has got 34.3? Yeah. So between 3 and 0, you're plugging the values, right? So that'll be into 5 over 6 t cubed. So I'm plugging in 3 and 0 into this equation here, right? With the C and F. 5 t cubed on 6 minus t squared on 2 minus 4t plus c. C is 34 and 3. Plug in your 3, plug in your 0. Plug in your 3, so that'll be 5 by 3 cubed on 6 minus 3 squared on 2, 4 by 3 plus 34 and 3. Then you plug in 0 and you'll get minus 34 and 3. Right? Then you're working out this will cancel. So you will get 27 by 5, that's 135 on 6, minus 9 on 2, minus 12. 17. What's up? Over 3. Right, so that's what your value will look like. Most likely it meters, right? So again, what should I do? Question after displacement, so I integrate velocity. And I got this. when I have this equation, you have to plug in what they gave you and solve for C. Right? When you solve for C now, this is your equation. All you have to do is what they said. They want you to find the distance or displacement. Find the displacement between 3 and 0. Just plug in 3 and then plug in 0. Work it out and you'll get 32 and 3. All right, nice job, Tabisha and Cheetah. Dimitri, you okay with us? Kiran? All right, feel free to go ahead and try the others. Right, next week I'm doing some more of this. Right, I like how it's looking. But I also seeing some people forget how to integrate. So please go by integration for next week. Right, I'm gonna do some more of this next week. Right, some more kinematics. Right, so